it is time to make some beautiful sweet boost with these now connected turbos. This is super exciting. So Ethan just went over to TurboSmart and picked up one of these bad boys. Not wastegate, boostgate. That is an all aluminum bodied 76 millimeter wide. Jesus. Basically like our straight gate on the exhaust, but this one is meant for the intake. The idea is that if this is going to the throttle and you want to limit boost, this has got 30 pounds of boost, open this up and the air comes out of this instead of going into the engine. So almost like a blow-off valve, but blow-off valve reacts to too much boost and vacuum in the throttle. This is actually limiting the amount of total pressure and flow going into the engine. All three of these turbos will all go to a joined up spot, and then this will be there to referee the engine from going insane. So now we don't have to have extra wastegate stuff, extra hot stuff, material, you name it. That really simplifies. And if this was a drag engine, which it might end up being, well, that's a lot of weight saved. What a really cool product, and I'm very excited to use it in a extremely ideal application. This is a good sign when your package is blessed by Felix Winkle himself. Joel had no idea who this is.
I thought that was my grandpa.
You know what's really funny though, is the rotary engine was originally conceived by him, Winkle, exactly 100 years ago. That's pretty fitting considering this is the biggest version of his concept. And so it was the Haltech guys who sent this. Every single rotor is going to get its own EGT. We also have the little bungs to weld onto each of these runners. And so that is going to come in very handy because this is the TCA8. We're going to have two of these. And 1 through 8 is obviously rotors 1 through 8. And then the other box is 16 more. So it'd be 12 rotors and then 4 more spares. And they're not actually spares. They're going to be coming off of the turbo to see how hot each of the turbos are getting. Every single one of all of these is going to be used. But because of Black Friday sales for Haltech, they didn't have this in stock. So we're waiting on the third oxygen sensor and the other one of these. And we have a full board and a full engine with data instead of shooting in the dark. And then there's another 4 already put on to the middle ones there. Now, one of the most important things is making sure that that tip is the same distance inside of each of these on every single one, because if this is sitting deep in one and shallow in another, you're gonna get totally different temperature readings, even though the energy and temperature is the same. But then we also have oxygen sensors. And so we'll have 3 total, but right now we're just gonna have 2. These aren't my favorite, but what is my favorite is the distance from here to here. So that part will allow me to have a oxygen sensor last a lot longer than it would if it was here. We're gonna know exactly what this turbo and engine is doing, and then we can push it all the way to its absolute limit. This is where it is at. Well, we'll get right to it. Aeromotive reached out about helping with the 12 rotor, and I couldn't think of a better company because when I think of mechanical fuel pumps, they are the first company and the only company that comes to my mind right now. And it's funny because the only other company is called Waterman, and they own Waterman. I will tell you right now, before we've even opened this, this is the 3rd largest pump that they've ever made. This is capable of 5,000 rotary horsepower at methanol levels of fuel, all while supporting 90 PSI base pressure. That's
bigger and smaller than I expected.
Yeah, that's both for me too. But you gotta think about that's not an oil pump. That is a fuel pump. So the gears mesh in the middle and then they bring the fuel on the outside edges. If the pump spins at 4,000 RPM, it flows 30 gallons per minute. 30 gallons per minute at 4,000 RPM. Even at 1,000 RPM, it's flowing 7 gallons per minute. To put that in perspective, the 4 rotor at full tilt used 6 gallons per minute to make almost 1,800 all-wheel horsepower, 6 gallons per minute. All this math basically means that we have enough fuel to run that entire engine on methanol and make 5,000 to 6,000 horsepower. So this is talking the talk and walking the walk. So this actually goes on the motor in a very fun, weird spot. It just plugs in. Oh, we got some challenges ahead of us. It's actually moving the belt. What we're gonna do is move this oil pump to kind of mirror the alternator, put the Aeromotive 30 gallon per minute pump behind that. So it's over here, we can see it, we can inspect every hose and make sure that our hose stay in line. With that, you can also get all the spark plugs easier, much simpler overall. Also with the oil system, we're adding an extension to the oil tank to let it breathe even more, because one of the weird things about this engine is that it's actually vacuuming air from each one of these little filters. And so that air has to get through that vacuum system and then go into the tank, and then the air is just breathing. It's by design on this engine. So we need to make sure that the oil doesn't get in the way of that massive amount of air. We just need to collect it on the wall or away from the breather. Now we have all seen this engine fire up, it is time to see what sort of power it can make, but it's not gonna do that right here. In fact, it's not gonna do that with the cart that we've got. So we are going to an engine dyno and we're getting this thing transplanted on something that can hold the torque in front of the dyno. We are taping the engine hoist to lift an engine stand, not an engine. And Rob has worked on making a thing for the engine itself, but right now that's not our problem. Our problem is what's in the truck. So this doesn't look too different than ours, except it's meant for the engine dyno. So it's actually got a couple extra safety features, as well as it plugs into the engine dyno itself. But thankfully we have these 2 points and that ring of death there. On the back end here, all of this aligns and locks into the engine dyno. I asked the owner if we could make this for ourselves. He was super hesitant, so we can transplant our stuff to it because it's close enough to ours.
Almost the same.
Yeah, it's close. It's really close. The spark plugs will have to move. This, of course, will transplant over, but we've got our work cut out for us. Well, I did virtually none of the work to get to this moment. Rob, not me, has gotten it ready for this. Now, the only other time I've ever used a lift to pull something massive was actually, a guy taught me that with the Diablo for replacing the clutch. You pull the whole drivetrain out of the ass of the car. This is just the engine. So we know the lift, obviously, from BenPack can do it, but it still feels so wrong. So we're just gently going to remove it from its earthly mortal coil. Roll so much easier on this thing. We are hitting the dyno week strong. Thankfully, we have Tyson here, the person who actually invented this. I'm just the guy who added turbos. Rob went and did all of the things to get this thing onto the correct cart, and that is done. That is solid. But Tyson went over to my good friend Renee's place, CX Racing, and picked us up air-to-water intercoolers, all the tanks already done, with this week being the dyno week. We don't have time to make 3 of these. Turbo dumps into one side, a different temperature air comes out, and ultimately goes into up here.
It's a good thing there's 3 of them, man.
I think that's not a good thing. I think there's a lot more work, but a lot less work making them.
Definitely. Definitely. Now I just gotta figure out where to put them.
These two 4-inch inlets need to go to 1, and the boost gate will sit on top of that. 2, 1, 3. Rob's gonna work his magic on that. Ultimately, what you'll see the most, the moment you see the engine, you're gonna see that thing sitting right up in the front of it all. We might be in the middle of one of the biggest crunches of our lives, but it doesn't mean you stop having fun. And so Robert decided to make me Patrick Star. That is exactly what that looks like.
It's so perfect. I don't even know.
Yeah,
I don't know how it came out that
it's
way.
both beautiful and goofy.
Yeah, I love it.
This side's beautiful, this side's goofy. That's hilarious. And so then now we have to give him a little penis.
Yeah, that's next. I just wanted to draw him a little bit. How to make it official.
This is just really shaping up to be something really cool. It's the wire I've been working on. And so you can see I've got, you know, a real nice clean thing. I've labeled it, and look at how the clear, look at this, the clear heat shrink. I just got that clean. Yeah, I'm really proud of this. While I was doing this, Joel actually went to JMD and got the transitions from 4 to 3.5, and it's got that nice little like volcano taper into this. And that's
It's like almost the right height.
Yeah, it's the right height. That was the part that I thought was really wild. So we'll just have the one vibrant clamp here, and then the other piece will be the air-to-water intercooler.
Looks great. It looks like a Cummins.
It does.
It does. Okay, so let's start with the reasoning. The reason I'm doing this is because if I have it this way, I simply just don't have the room. I could even like 3.5 off of this to keep it like shallow as possible and then do this transition here, but I still just don't have the room here. If we didn't put this on so soon, I could have 90'd directly from the housing, and it would have been perfect.
Just by the nature of the way that everything is asymmetrical with the turbos, kind of set us up for a little bit of a challenge. And so one of the challenges actually is the fuel tank is right in the same spot where that other water to air intercooler would be, but it's already so much further from the engine than that side. If we were to move this core over here, it'd be sitting way out here. I want this thing to present well, so I think we can still maintain most of the symmetry and deal with two major issues: is this cooler being in the wrong spot technically, and this exhaust also being in the wrong spot. It's gotta get over here. You know I'm serious when the glasses are on. Plugged in the boost gate. There she is, completely locked down. It's at 0%. I'm actually kind of curious. There's the slightest bit, like the slightest bit of leak, because that's the question. Like if you use a throttle body for this roll, the throttle bodies naturally have bypass, so the engine can idle, or even when they fully shut, they're still not solid. This has a nice taper, so it sits on that, and quite frankly, that's a very small boost leak. Check this out. We're gonna go ahead and recalibrate it. Just for anybody wondering, I actually picked the 76 millimeter straight gate for the exhaust side. So Haltech doesn't have the boost gate side yet, but it's the same device, just much beefier, meant for stopping the exhaust from going to the turbo. This 100% gravy train, and then this stops it from getting to the engine. So same but different. So then I'm gonna go ahead and calibrate it, and you guys will just see what it does. Calibrated. So that is only running off of 22 gauge wire. And as you guys may have remembered a while back, Haltech has an option where you can control even that with 25 amp circuits back and forth. And it is violent. If you're trying to use that, you're band-aiding a bad boost control strategy. But at this point, I mean, that's the only thing stopping us from 100% pure boost on this motor. I imagine, and just based off of the 4-rotor, that by 6,000 RPM, this thing will still be closed if we're going for full power, but then above that, we need to make sure that it does escape, that it can stop the engine from just going full all out. You know, it needs to control the boost. Such a cool piece of technology, and we plugged it in and it worked perfectly. This is a motor that looks like it makes a lot of power, well, except for just the tacks. Granted, it's all over the place, but it is all over the place with purpose. We will be simplifying this as we go to the next phase of its life, but for this phase, we're gonna have ice cold air meeting up in the star pattern. This thing will stay closed as long as I feel comfortable keeping it closed. And then the rest of the air is gonna go straight into all 12 rotors. So this is beautiful. This is monumentous for all of us. We've got a lot of things that we're gonna go through, pause, make sure that we're not rushing, and make sure that this thing can just go straight to the dyno and make a shit ton of power. I am sometimes a really bad customer, and this embarrasses me because I owned an IT business with 25 employees at one point in my life, and yet my dear friend Richard came here to help me diagnose something, and it was my fault. Could you share with the world what I did?
Well, the technology executive, he tried 3 different chords, and all it took was me bringing another chord to solve the issue.
That was it.
I'm gonna leave you this chord. You can keep this chord. Okay. I have more just like this. So yeah.
That thing got loud. It really got. It was like.
I was like, it was just getting more progressive and loud. I was like, is this a joke? You guys are messing
Nobody else
with me.
is noticing this shit.
Okay.
Okay. So then now. That's crazy. It worked perfect. It never didn't work perfect.
Thanks, Rode Audio, for this beautiful USB cord.
You know what's funny is the box comes with a cable. I think, right? No?
Don't throw me under the bus
Okay,
like this. It does
yeah.
not.
I was like, shit. Shit, okay. Yep.
Yeah, me thinking no.
Okay.
But yeah, now you can actually change all the settings that I was telling you all about.
it is go time. So we're going through systems check right now, and this is the coolest one. This is now pumping oil and fuel from Aeromotive. That quite literally is the amount of horsepower taken by these pumps. It's inevitable, one way or another, to pump fluid requires power, but the thing you gain is a running motor. So the mechanical fuel pump is actually already, with spinning this slow, pressurizing it to 90 psi, where the pump in here, which is badass brushless one, pumping it up to about 87. So it just shows you that 30 gallon per minute pump can flow more down low and up high. So that's excellent. The oil system, we're just using some of our Valvoline break-in oil. It's thinner than the 2050, but it'll certainly do the job. Rob's finishing up the whole intake Patrick Star. I'm going to open the main throttle, and it's currently partially open for idling. This one's basically closed. And then as it opens, you'll see this one catch up to it, and then at the top, they'll both be wide open. So you should be able to see a delay.
Yeah.
But when I go to like half, they're both moving.
Yeah.
Yep. For the nerds that are watching this, I'm literally telling this one to open based on this one's position. So what happens is this one starts moving, finally gets to the right spot, sends that signal to the computer then says, oh, hey, he's in the new spot, move this one. And so that's just the nature of what I'm doing instead of running both parallel. So that way this one will idle. This one won't even open or close until this one gets over 20%. Above that, let's let the boost build. Throttles are looking good. The E-gate was the easiest thing in the world, the boost gate. And then the fuel system instantly primed. Like Ethan turned it over probably 2 or 3 revolutions, and mind you, there's air and the filter and everything. It sucked that much fuel through it and primed the fuel system 5 psi. Oil system's looking great, 50 psi, which is what we were expecting before when we did the drill. As soon as I plug in the igniters, it's ready to party. We have the largest rotary engine, essentially in the world, ready to make power. So we're gonna do the last couple of things before we go to the dyno, but we're gonna fire it up, do all the usual tuning things, and close this, give it some revs, and see if those turbos can create that beautiful feedback of making power even just sitting here. There is a lot on the line because two of the smartest people that I know are watching me. One's my dad, and the other one is basically the father of the 12 rotor. They're both judging me. So, I mean, you know, whatever. It's just like, you know, people that can do this better than me are just watching and we're like, no, you go ahead. See, what are you gonna do? I got to do my best to make this sing quickly and not blow it up. And you know, your parents are watching. We are doing something a little bit more. And so it's a little cold here, not that I'm using it as an excuse, but it is 50 degrees out and engines have a harder time starting when it's colder. We are gonna go to 36 volts. My dad cleaned up all the contacts on these wasps and they're doing the best they can, but they're literally doing 100%. And so the only way to make it do more than 100% is to step up the voltage. And so we're actually putting an anti-gravity in line. So one of these will get 36 volts and it's full, whatever, 180 amps. So that ends up being almost 3 times the power of a 12, but it doesn't work exactly that way. But we're just gonna give it all we got.
So this is on.
We've been kind of trying to start this with one hand behind our back. The engine's been flooded since the last time we started it for the original video. And so every time we try to start it, we're getting a little fuel, and it's just flooding it out. So what we did is we pulled all of the spark plugs out, and we are going to spin it over, fuel and ignition off, and so it's gonna be loud. You guys might not hear it because of the way the microphone will cap, but it's gonna be loud. We've had our asses kicked, but more importantly, it's 50 degrees out, and that motor is ice cold. What we are doing is we are going to run hot water from the faucet. Instead of using the faucet water to cool the motor and as a radiator, we're actually using the reverse radiator and heating the motor. When the engine's this cold, not only is it contracted and it's tighter, it also, when the fuel hits anything or it's in that area, it's going to condense easier. It's going to collect very quickly. So if we can get the motor up quite a few degrees, that'll make this a little bit easier to start. But with that, we've completely flood cleared this thing, and then Tyson made basically a fuel injector on the tip of the starting fluid. So it's not just a stream, it's actually really more atomized. We got water pumping through it. Wow, that's good old aluminum for you.
Oh wow.
Yeah.
What the heck? You can physically feel that. I thought you guys were.
Wait, Dad, show the camera.
About 97 degrees in. The block is nice and warm. It's 70 degrees.
Yeah, a lot better than the 50 that it was. That's wild feeling. At this point, we are trying just about everything we can. We're getting our asses kicked. But I think tomorrow will be a new day, and we'll come back at it and try some new, unique things. Tyson really wants to try using a paint gun to spray fuel into the engine. So that might be our little secret golden trick to getting this engine fired up. Here we go.
Holy shit!
I guess I was right.
Everybody okay?
Yeah. That was.
Holy shit.
Backfire?
Oh my god.
That was the
backfire.
intake manifold.
That's a backfire.
Oh my goodness. It's not a front fire. Wow.
I don't even know if I have words for that. That was absolutely insane. Unfortunately, it's again the victim of engine cranking too slow, so the trigger wheel is trying to figure out its position, and then it fires them off until it resets, and then the fuel was doing what it does. This is actually probably the biggest type of problem I keep having, which is backfiring through the intake, just not on this scale. Now, I want to point out, that's probably the best thing that could happen. If this was built much stronger, you're going to pressurize everything more. So obviously this sucks, but truth be told, I'd rather have that happen than it hurt the motor or do something really, really bad. I can't tell you how much pressure that was, but it was way, way over 35 PSI. We got the air to fuel ratio mixture correct in here, not so much in here. You know, everybody's gonna be a little apprehensive about doing that again, rightfully. So the question is, what do we do different this time? So we're gonna fix that back up. We knew this thing would be violent, I just didn't know it'd be that way.